for a of our function?
Oh, A is 20.
20.
Wait. Oh crap. I forgot stuff now.
So f of x equals, okay,
I'm sure.
20. What do we find with b of our function?
1.8.
1.84. So, Joe, can you please take off your hood? Please take off your hood. So, thing to remember, this is b is never just your percentage. It's always going to be 1 plus your percentage or 1 minus your percentage, depending on what the situation is. So in this case, we were increasing. So it was 1 plus our percentage of 0.84. So we had to move it to a decimal. So 0.84 to 1.84. And then what did we raise it to? 3, because it was 3 years. Now we plug this whole thing into our calculator, and what do we find was our solution? 124.59. Do we have 0.59 of an animal though?
Yeah.
Yes. Now, so we are going to estimate it. So we are going to round from here, which will round down because we don't have a whole 125. But we're pretty close. Are we okay with this warm up?
Yep.
All right, boys with the bees, put them away. I don't want to see them out. Don't throw it, Ashton.
Detention, give him a
I don't want to see him out.
Give him a detention. I'm like
All right. So this was our function that we dealt with, our exponential function that we saw the other day. We talked about how f of x was your output, you had your initial value, your common ratio, or your rate that you were always increasing or decreasing by, and then our input. Today we're going to talk how to graph exponential functions. So we're going to get some graph paper out, we're going to learn how we can graph these and how it's different from our other graphing that we've done in the past. One thing to notice though, your a, this is always going to be your y-intercept. So that first value of your function is always going to be the y-intercept of your function. That's always going to be where we cross our y-axis. So that's an important thing to remember when we start graphing things. So I'm going to hand out some graph paper to you really quick. Just give me a moment.
pass, please, pass. No, you pass. Stop it. You're going to mess around.
All right. So A will always be our y-intercept. B is going to be always our ratio. It's important to know what that ratio is and how to use it. Sometimes we might need to use our calculator to graph these. Sometimes we can do it by hand. We'll talk about the ones that we'll have to use the calculator for a little bit later on. So we're just going to start off with the generic f of x equals 2 times 2 to the x. So when graphing these types of exponential functions, we always know that first number, that a is going to be your y-intercept. So you, just like what we did with slope-intercept form, always graph your y-intercept first. So I know 2 is going to be my y-intercept, so I'm going to plot that on my y-intercept. If you need a table, if a table helps you, then you can make one off to your side. Your y-intercept is always going to occur when x is 0, so we know x at our y-intercept I'm going to add 2, so I'm going to fill in this table while I graph as well, just in case if a table helps you forget that. So, what is my ratio? What am I always increasing by on this function? 2. So I'm doubling. Every time I go over 1, I'm doubling whatever I started with. So if I start with 2, next time I double it, I'll have 4. Next time I double it, I'll have 8. Next time I double it. So 2 is our ratio that we're multiplying by every time. So, like I just said, if I increase over 1, all I need to do is just double what I originally had. So if I double 2, I get 4. If I double that again, I get 8. These points, I know how to plot on here. So let's see, 1, 4 is right here. 2, 8 brings me all the way up here. If we notice, these lines will increase very quickly. They won't be straight. They'll have that curve to them, but they'll get sharp very quickly. Now let's think. What if I was trying to figure out what my line would be in the negative direction for these negative numbers? I can divide by 2. I just need to go sort of do the inverse operation, work backwards. So normally I'm multiplying, but if I divide 2 by 2, give me 1. If I divide this by 2 again, I'm just going to get 1/2. So negative 1, 1, right here, and negative 2, 1/2 is roughly right there. So far on my graph, this is my exponential function. Now I could keep going in my negative direction. I could think, okay, right now I have 1/2. What's a half of a half? Like a quarter. And another half of that, and another half of that, and another half of that, and another half of that. I'm getting smaller, 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 smaller.
However, you can never truly read nothing when it comes to taking away halves because you're not taking away the entirety ever, it's just half.
Good. So we're always cutting in half every time. But every time you cut in half, there's still a little piece left over. That piece is just getting smaller and smaller and smaller and smaller, but it's never disappearing. It's getting very, very, very finite and very, very, very small, but it's still there. So as we graph this, we're getting very, very close to 0, but your line will never actually equal 0. So when graphing, it's very hard to represent that because it's hard to represent, okay, what's like 0.00001 of a number? Well, it's very close to that line, so typically what you do when graphing is you just sort of flatten out right above the x-axis, but you're never actually going to touch 0 on this graph. So your y is never going to be equal to 0, but it's going to get very, very close. So just draw your line as close as you can to that line, but it's never actually going to touch. And that's all there is to graphing an exponential function. So we start with that y-intercept, figure out what your ratio is, how much are you increasing by? You're doubling, tripling, cutting in half. If you need to, make a table to help you. And then from there, you just plot your points forward and plot your points backwards, and you're done. Do we have questions over anything I did at the moment on this? Let's look at another example. So we have 3 times 2 to the x. So what is going to be my y-intercept for this point? 3. So that a value, that's our y-intercept. So I can put a point right at 3. How is my function changing in this situation? Times 2. So I'm multiplying by 2 every time. So if I take 3, multiply that by 2, 6. Gives me 6. Multiply that by 2 again, gives me 12, which is way up here above my graph. If I think about going backwards, if I cut it in half, it's like half of 3 is 1.5. Half of 1.5 is like 0.75-ish. Half of that is 0.36. So with some of these, when you're trying to, the goal is just to estimate. Obviously, I don't know exactly where 0.365 or whatever that number is on my graph. I'm just estimating. I'm just getting close. So I don't expect these to be perfectly accurate when you're getting into the decimals. If you want to, you can use your calculator to help estimate what the actual number is. You can take your 3, divide by 2, divide by 2 again, divide by 2 to help figure out what these numbers are. But I'm not expecting it to be perfect. I just want it to be close to that area. And so this will eventually bottom out, and it'll just sort of flatline. Because we'll always get very, very close to 0, but our graph will never ever touch 0. It will just get very, very close. Because we can't cut it in half. Are we okay with graphing this one?
Sure.
So it's very similar to the other one. The only real main difference was our y-intercept was different. So switching gears for just a moment. So student named Jeremy, he doesn't like math class. He's always trying to skip math class and leave early.
That's mean.
So his teacher tells him that
Jarvis, you're
he can, at the start of class, he can stand 5 feet from the door. And every minute, he can cut that distance in half. And then he can leave once he's outside of the door.
That's hilarious.
Should he take this situation?
No, he shouldn't because it's half, so
You never ever get to the door.
yeah, you're always just going half.
I would just walk.
So he would never actually reach the door. He'd start 5 feet, and then he'd cut that in half, and cut that in half, and cut that in half, and cut that in half, cut that. But every time he's only decreasing little by little by little by little by little by little, like he would never actually get out.
Jarvis, good job.
You touch the door. That
So,
was a great example.
thank
You
you.
touch the door.
So with this, it's just like our exponential functions. They're getting very, 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 very close to 0 when you got them, but they'll never actually reach 0 at any point in the situation. That's just a funny.
I did it.
You should have called him Timmy or Little Timmy. Little Timmy.
So what is different about this one?
It's the half, it's on multiple.
We're multiplying by 1/2 every time. So rather than increasing, we're decreasing. So how do you think it's going to look different?
It's
It's
just
gonna
gonna
go
go
all the way.
like other way.
So rather than going up, it's going to start high and end low. So it's just going to be flip-flop. You already have your P and J.
Hey, okay.
All right. So what's our y-intercept for this graph?
graph?
Do you want to try to graph this one on your own or together?
Together. I'm not listening. Hallie.
All right. We'll do this one together, and I'll let you do the next one on your own. So y-intercept. So always that first number. It's 4. Once again, the way that this one's different is it's multiplied by 1/2. So we're cutting in half every time rather than increasing in this situation. So we have to think, what's half of 4? What's half of 2?
1.
And then half of that is 1/2. And then we get smaller and smaller and smaller and smaller. Then we can think of the backwards. What's if we divide by 1/2? Dividing by 1/2 or dividing by a fraction is the same as multiplying by its reciprocal. So if you flip this around, it's the same as multiplying by 2. So what would be doubling 1/2? Or yeah, we'll have these in our equation, and then above that would be 16. And so our function is going to look something like that, except better than mine because mine doesn't look good. So it looks the exact same. It's the same shape. It's just flip-flop this time. It's spun around. Do we feel okay with this? All right, let's put the bees away. I don't want to see them out. All right. So this next one. I want you, using your skills that we practiced yesterday, create the function. So thinking what the function would be, and then seeing if you can figure out how you would graph that function based off what you end up with. So create your function and then see if you can graph your function. All right, let's talk about this question. So what do we find for our function to start off with?
F of x equals 9
9 times
times 0.23.
Raised to the x. So it's 1 minus 0.77. So the first thing you always graph is that y-intercept. So the first thing you should graph is that 9. So you plot your 9 in there. Now here's the tricky part. For the rest of these points, we don't really know what the value is because we're multiplying by 0.23, and I don't know about you, but I can't really do that math in my head very quickly. And follow me. So what you can do is you can take your calculator and you can type in 9 times 0.23 raised to the first. So 9 times 0.23 raised to the first, that's like 2.07. So that's just above 2. So I know if I go over one space, I need to go up 2.07. Then you can type in 9 times 0.23 raised to the second power. So we can go over 2 spaces, and that gives us like 0.47 something. And we can plot that number. You're going to get very close. You're going to have to estimate a bit. You might not know exactly where that point is. I don't know exactly where 0.47 is going to be on this graph, but I can get close. From here, I can assume I'm just going to bottom line at this point. My graph is going to look something like that, except without the bump. So sometimes with these questions, you might need to use your calculator a bit. You might need to estimate where those points are actually going to fall. Most of them, we should be able to gauge where they actually should go, but once you get to a certain value, you're just going to have to guess. I know, it's pretty bad. But the main thing is being able to determine what is the function, find that y-intercept, figure out what am I multiplying by every time, and then actually help you. You just need the graph. You just need your calculator for some of those numbers. Once again, making a table can always help if you need that. Are we okay with this? Do we have questions on this one? Okay. All right. What's different about this function?
Start with -3.
Your intercept is a negative. What do you think? How is that going to change your function?
Goes down.
So what is it going to look like? It's going to start on the bottom.
Upside down.
It's going to start on the bottom, going up.
You think it's going to go up?
Yeah, no, it depends.
No.
It depends. Depends if it's going negative.
All right, let's see.
Should be on.
So we start at -3. We are doubling. We're multiplying by 2. So what's -3 times 2? -6. That means I'm going farther down in my negative direction.
And then you go into infinite.
If I multiply again, I'm going even farther down towards -12.
Oh, that is.
Once again, if we think backwards, cutting in half, if I'm dividing by 2, I'm still negative. I'm still going to be negative for this whole thing. So if your A is a negative number, your graph is going to look the same. It's just going to be flipped upside down. So once again, if you have your B is a positive number, if your B is a whole greater than 1, you're going to be increasing. If your B is less than 1, you're going to be decreasing. Same thing though, if your A is negative, you'll still be increasing, but you're going to be going down. Unless your A is negative and your B is less than 1, then you'll be like starting from really low and going up but getting closer to 1. So depending on what those values are, depending on whether B is greater than 1 or less than 1, or A is positive or negative, might change the location and positioning of your graph. But from there, it's still the same steps, it's still the same practice, you still do the same thing, it's just you're going to be on the bottom half of your graph. Are we okay with this?
Yes.
All right, let's try. Oh, okay, right. So, we can graph a lot of things by hand, but some things are just really annoying to graph, some things it's just not fun. So we can also graph on our graphing calculator. That's why we have these things. So we're going to talk about how can we do these on our graphing calculator. So if you take your calculator, on the top left corner, it has your y equals button. Oh, not all of us have graphing calculators. All right, for those of you who don't have one of the graphing calculators, go over to Mrs. Rick's room and grab one of the graphing calculators. I'm sorry for those of you. I should have thought this was good.
Run.
Yeah.
Supposed to be running.
That's
not nice.
All right, so everyone should have a graphing calculator. In the top left corner of your graphing calculator, the top button is y equals. hit that button and it should take you to a plot, or a spot that says plot 1, plot 2, plot 3, and it should say y equals, y1 equals, y2 equals. In there, you are going to type in your function. So, to start off with, we have -7 times 0.84 raised to the x. So that's going to be our function we're going to type in. So you can type in -7 times 0.84. Then you can use your caret symbol to do raised to the power of x. Once again, your x is going to be right under the right next to the alpha button. Because the green alpha button to the right of that is your x button. And that will put an x into your function. So you should have -7 times 0.84 raised to the x into your calculator. So we're going to do -7 times 0.84 use the caret. So once you get that calculated into your table, you can hit, if you look on the right upper hand corner, it says graph. If you hit graph, it should then hopefully graph it on your, depending on how your Windows is, it might, you might not be able to see it. Windows 95.
Oh my god! Keep it straight line! Are you gonna straight line? Oh my god, what the hell? Oh, but I did not agree.
So make sure all other lines are deleted from your graph as well. So you're probably going to get something in the bottom right-hand corner of your graph. So you will have these on your state test. So if you don't want to graph something, or you just need to look at what your function looks like, but you don't want to have to graph it, just plug it into your calculator and hit graph, and then have it graph it for you rather than doing it.
That's so good.
So you hit -7. It wants you to hit everything you need to do is negative. So one other trick that these calculators can do. Say you need to figure out what this graph is at 3, and then say you also need to figure out what the value is at 4, and also the value at 7, and also the value at 8. So rather than having to plug all of those values into x and plug them into your calculator and figure out them by hand, if you hit second and then go to graph again, right above it says table. So every time you do the second button, it does whatever it says above. So second graph brings up a table, and it has all of the values for your graph. So what's the value at 0, what's the value at 1, what's the value at 2. So rather than having to graph it by hand, or rather than having to create a table by hand, you can use this to do it for you.
And we have these on the state test.
You will have this calculator on the state test. So if you remember how to do this, then that could be a good benefit to you. Yeah.